Good morning and welcome to today's webcast, Managing the Transition to CCAP and DOCSIS 3.1. I'm Mike Roebuck, Senior Editor with CED. Today's webcast is sponsored by ARRIS. Just a couple of quick programming notes before we get underway. There's a button to make the presentation screen larger on your console there. You can also download a PDF version of the webcast slides, and there's also a white paper for you to download if you're interested. Make sure you ask questions throughout. We'll do the Q&A near the end of our hour. And this webcast is going to be archived on CED's website, cedmagazine.com. So we have a very timely discussion, I think, today with the pre-symposium going on at Expo later this month on DOCSIS 3.1 and with where we are on the technologies and product developments. Great panel. We have George Salinger from Comcast who's going to give us an update on the status of 3.1. He's also going to talk a little bit about the migration from 3.0 to 3.1 and spectrum allocation, another key element. And then we're going to switch over to Carol from ARRIS, and she's going to discuss about how 3.1 will impact home installs. And lastly, we have David Clausen from Charter. Happy to have him aboard. He's going to discuss Charter's take on CCAP and 3.1. So I'm going to jump out of the way, and it's going to be over to you, George.
Great, thanks, Mike. Good morning, everybody. So I guess the first question that you may wonder is why DOCSIS 3.1? What does DOCSIS 3.1 do that DOCSIS 3.0 or previous versions of DOCSIS doesn't do? And the answer is DOCSIS 3.1 was designed for gigabit per second service. While we can achieve gigabit per second capacity with DOCSIS 3.0, we can certainly provide with DOCSIS 3.1 gigabit per second service. And how do we do that? Well, one of the first and most important reasons is because we get much more efficient use of spectrum, up to 50% more bits per hertz than DOCSIS 3.0. This is possible because of two things, fundamentally two things. One of them is the change of the forward error correction, which has served us very well. Reed-Solomon forward error correction has served us very well, but it is what was available at the time we started with DOCSIS 3.1, and since then, a lot of advances have been made, and certainly the compute power in the chips has made it possible to run forward error corrections such as low density parity check, LDPC. And the second is higher order modulations. With DOCSIS 3.1 we can run 1K QAM, 2K QAM, 4K QAM in the downstream, and up to 1K QAM in the upstream. Higher modulation orders are possible, and the spec describes them as options, but these are the required specs. And for those of you that have been around for a long time, you may remember that at the beginning we weren't quite sure if 256 QAM in the downstream was going to work, or even if 16 QAM was possible with initially DOCSIS 1.0, and here we are running such high modulation orders. It's unbelievable. The other two additions that are very important is the use of multiple modulation profiles, or the development of multiple modulation profiles, whereby each CM will run at the most efficient modulation profile that is possible. So not all CMs have to be running at the highest modulation order in order for all CMs to use it. So even if some CMs can use a higher modulation order, it is possible to use that one with the addition of multiple modulation profiles. And then larger spectrum blocks. We've been using 6 megahertz channelization because that's what we had in the plant, and that's what we've always had in the plant. But as we move through higher and higher number of channels, it is really not necessary to be tied to this, this channelization. And going to larger blocks gives us the ability to use the spectrum more efficiently. So in the downstream, an OFDM block is as wide as 192 megahertz. And it's configurable. You don't have to use the entire 192 megahertz to use any part of a block. You can use much less than that, and the minimum is 24 megahertz in one block. And DOCSIS 3.1 supports, at the very least, 2 of these 192 megahertz. So the initial chips even will support, up to almost 400 megahertz of OFDM. In the upstream, the blocks are 96 megahertz wide, and the specification requires that 2 of these blocks be supported. These are also configurable, and there's also time and frequency division multiplexing. In other words, not only can you allocate spectrum, different parts of spectrum for, DOCSIS 3.0 or DOCSIS 3.1, but you can also overlap them, sort of along the lines of what we did with logical channels before. So you can use regardless of what you are using already for the upstream, you could allocate the entire upstream for DOCSIS 3.1, and the scheduler and the CMTS will take care of scheduling transmissions from the different modems in a way that they don't, overlap. The addition of OFDM, which has been used by other technologies quite extensively, allows us for better noise immunity. So we move from QAM to OFDM and DOCSIS 3.1. And then the support for legacy single carrier QAMs. This is a very important part of DOCSIS 3.1 is the development of backward compatibility. So legacy single carrier QAMs will be supported by DOCSIS 3.1, so that, for example, we can have only, if we wanted to, deploy CPE and only use it with DOCSIS 3.0 downstreams and upstreams, or we could deploy the head-end equipment and only support 3.0 and upstreams and downstreams, or support 3.0 and 3.1 upstreams and downstreams. This is all relates to the backward compatibility, which I will expand in a later slide. DOCSIS 3.1 is speaking with my Comcast hat on, DOCSIS 3.1 is one of the technologies that we will be deploying. It's actually the main technology that we will be deploying moving forward for high-speed access. What's the current status of DOCSIS 3.1? Well, actually, it's very, very advanced. It's the spec that has moved the fastest. It's the one that is being developed the fastest of all of the DOCSIS specs that we've worked with and deployed in the past. From a spec perspective, they're mostly done. CableLabs is still working. There's still some work going on at CableLabs, but it's really on ATPs and to complete the OSS specification, which has already been released. All the other specs have been released, and in fact, there's been multiple releases of them. At Comcast, we've added DOCSIS 3.1 in the CCAP specification, and now we're working on the CPE specification to add DOCSIS 3.1. From a silicon perspective, it is well under development. There's at least 3 CPE silicon suppliers, and there's multiple head-end suppliers working on silicon. There's more competition than ever before. We do expect the first silicon to appear in the market sometime in the first half of 2015. CCAP systems are also well under development. As expected, hardware and upstream will take longer than software and downstream. In other words, whatever is a hardware upgrade will take longer than a software upgrade, and whatever is upstream will take longer than downstream. We do expect downstream implementations, at least some of them, to be firmware upgradable, and we expect them to be available on or about the third quarter of 15. CPE might become available quickly this time around. We don't expect a big cost delta. This is very important between DOCSIS 3.0 and, as we saw, between DOCSIS 3.0 and 2.0. If you recall that at that time the delta was pretty big, and that was because a lot of the modem needed to be developed that didn't exist. For example, wideband tuners, wideband modulators, these things didn't exist. We only had one upstream and one downstream channel. And that's not the case with DOCSIS 3.1. All of these features are already in existence, and in fact, the DOCSIS 3.1 modem, it is going to be mostly about changing the DOCSIS chip, and the rest of the modem will naturally follow its evolution. There may be in gateways, there may be a new version of Wi-Fi, for example, or a new version of MoCA, but otherwise the change from one gateway to another will be pretty transparent. The migration from DOCSIS 3.0 to DOCSIS 3.1 will be pretty gradual, as it has been in the past. For example, now we all have lots of 2.0 modems, lots of 3.0 modems, and perhaps a few DOCSIS 1.0 and 1.1 modems. When DOCSIS 3.1 CPE becomes available, which will likely be first, we can deploy it in DOCSIS 3.0 mode. In other words, take advantage of the fact that DOCSIS 3.1 modems support single carrier QAMs and deploy them in the network in a DOCSIS 3.0 mode. Then eventually DOCSIS 3.1 head-end equipment will become available, and when that is the case, then we'll start using the 3.1 capability in DOCSIS 3.0 modems. But existing modems will continue running because the 3.1 CMTS will support 3.0 upstreams and downstreams, as I said before. Eventually, we'll add a lot of 3.1 modems, and perhaps we'll use the downstream first, and then use the upstream. And eventually, upon it being needed, we'll expand the upstream and downstream capacity in the networks. This is an option. It's not necessarily a requirement. This should be it's one of the messages that we want to make sure that it's pretty clear is that DOCSIS 3.1 can be deployed in current HFC networks as we have them today. Of course, if you expand the capacity of the network, then you'll have more capacity. And if you improve the operation of the network, as always, then the network will run more smoothly and we'll be able to have more capacity than we would if we didn't. Spectrum allocation is definitely one of the big things. And here's an example of how DOCSIS 3.1 could be deployed. In the downstream, DOCSIS 3.1 could be deployed in the available spectrum and bond with the 3.0 channels. So as an example, if we had 24 single carrier QAMs and 100 megahertz of OFDM, that would equate to, the 24 single carrier QAMs would equate to about 900 megabits per second of capacity and the 100 megahertz of OFDM at an average of about 8 bits per hertz, which assumes about a 1024 QAM operation. Would be another 800 megabits per second. The combined capacity is about 1.7 gig, which should be enough to run a 1 gigabit per second service. For the upstream, I want to stress that we don't have to deploy the upstream until later. We could deploy DOCSIS 3.1 downstream without having to deploy DOCSIS 3.1 upstream. So we could use DOCSIS 3.1 downstreams without having with DOCSIS 3.0 upstreams. But if and when upstream DOCSIS 3.1 upstream becomes available, all of the spectrum could be allocated for DOCSIS 3.1. So for example, a 32 megahertz of OFDM from about 10 megahertz to about 42 megahertz would be about 160 megabits per second, assuming about a 5 bits per hertz of efficiency, which is a pretty reasonable and conservative approach. So this picture shows what we might have in the network today, and the upstream on the left and the downstream on the right, where the green and blue represent the out-of-band, and the light green bands represent digital video, and the rest are all QAM. So that's what we may have today: 3 to 4, in some cases 2 downstream channels, and 8, 16, 24 DOCSIS 3.0 channels. So DOCSIS 3.1 downstream could be deployed in whatever spectrum is available, either through reclamation. Most operators are doing some reclamation of analog, so that's why I located OFDM 3.1 in the lower part of the spectrum. But through the reclamation, you may move channels and still put everything up in the high band. And then for systems that are that have spectrum available in up to 750, or systems that are 860 or 1 gig, then we would have more spectrum available on the upper part of the spectrum. Once it's available, OFDM could be deployed in the upstream, occupying the entire upstream, and time division multiplexing with DOCSIS 3.0 upstream bursts. And then if and when we decide to expand the capacity of the network, whether it be in the downstream and the upstream or both, then we would have more spectrum available for both things. With respect to the focus areas at Comcast, we're actually working on a plan to deploy DOCSIS 3.1. We think that we'll be in a position to do field trials as soon as the equipment is available around the middle of 2015. And so we're working with equipment suppliers to make equipment available as quickly as possible. We're doing a lot of work on our HFC network, and we want to make sure that we have the required spectrum available. So clearing out spectrum through a bunch of things. We've already gone through an analog reclamation. We're now going into an MPEG-2 to MPEG-4 HD conversion to make spectrum available that way. We're working on the field operations aspects of this, and by that I mean trying to figure out what are the metrics, the appropriate metrics that we should be focused on. Two big things are different. One of them is we have OFDM signals instead of QAM. They're very similar, but they're not exactly the same. And then the other is the amount of spectrum that is monitored. We normally monitor, for example, SNR or MER across one or multiple 6 megahertz channels. Here we will have in the downstream a channel that is 100 megahertz wide. And so how do we do that? What are the appropriate metrics? And then from there develop the appropriate standards. And then determine what tools will be required for telemetry installation and operation. Network management is going to be substantially different. Capacity is going to be different in 2 different ways. One of them is we will have much broader capacity than we did have before, but the second is not all modems will see the same amount of spectrum or will see the same capacity and the same amount of spectrum. And then testing and equipment certification, both at Cable Labs and at Comcast, are areas in which we need to work on and develop a plan. So in this slide, I have my email, so feel free to send me any emails. We will take questions at the end, but if after this session you have any questions, feel free to send me an email. And with that, I'll turn it over to Carol Ansley. Carol.
Hello there, everybody. I'm going to talk a bit about how the changes in DOCSIS 3.1 could affect home installation. And DOCSIS 3.1, as George was just discussing, it was designed to increase the throughput and just the raw bandwidth that you can get through the HFC plant. And it gives you a lot of choices about how to use the plant to both drive more video and more high-speed data. And I think I'll just go ahead and show the next slide. So if you look at what DOCSIS 3.1 proposes as a part of the overall standard, today, and this is similar to George's slide again, you've got upstream from 5 to 42, you've got downstream from 54, and different people will be 750, 860, some people up to a gig. And then a lot of people have MoCA deployed for whole home DVR and other services like that, up above a gigahertz. Now DOCSIS 3.1 moves in two directions. It allows the upstream, and this is what is required to be supported in the modems as well as in the CMTS. You don't have to pick it up immediately, but the support is going to be there. There's going to be support on the upstream to go up to 85 megahertz. And on the downstream side, it can now go well above a gigahertz, with the eventual goal down at the bottom of the screen of showing a upstream spectrum that's been effectively doubled. And in the downstream, the lowest part of the downstream will end up being given up so that you can get that expanded upstream. But on the high end of the downstream, there's a lot of other things that can be done. And I'm going to talk about these two changes and how it can affect you in the home installation. So if we take a closer look at the changes for the DOCSIS 3.1 upstream, there's upstream support for several different choices in the DOCSIS 3.1 spec. And we're talking here about DOCSIS 3.1, but DOCSIS 3.0 actually had support for 85 megahertz as an optional item. And in DOCSIS 3.1, 85 megahertz went from being optional to being the required option. Now, there is a potential issue with interference between 85 megahertz transmissions and the in-home receivers. So you have to consider, if you're going to go ahead and start moving toward 85 megahertz, some of the potential pitfalls there. First, within the home, there's the potential for interference with the in-home devices. If you have a cable modem that's transmitting, and for illustration purposes, I've used the maximum transmit level across 24 megahertz, which works out to 59 dBMV, 59 dBMV across 6 megahertz. When the modem is transmitting at that level, heading back upstream, you always have crosstalk or reflections within the in-home splitters. And as an example here, I've shown a splitter with 20 dB isolation. You may have better splitters. You may have the occasional splitter that doesn't quite meet this either. But just for the purposes of illustration, you can see that because of just the inherent crosstalk within the splitter, you're going to have high levels traveling back to the other devices in the home. Now, this happens right now when a cable modem transmits in the current 5 to 42 band. And all the devices have been designed expecting those signals. But with the 85 megahertz transmitter, when it's transmitting above 42 megahertz and crossing really above 50 megahertz, this is part of the receive band of these older devices. And when those devices see that substantially higher level, if there's no filtering, it can cause interference. And similar to the issues that we're seeing in some of the early MoCA deployments, these unexpected signals, even if the set-top box is currently tuned to, say, 400 megahertz, it can still cause interference with these legacy receivers if they're, substantially higher than the desired signals. So this is one potential issue that needs to be kept in mind as 85 megahertz devices are deployed, and particularly this is more when you turn them on. There is one other issue that I want to mention, and in George's presentation he mentioned that a lot of folks may want to go ahead and deploy 3.1 modems and still keep using them in the 5 to 42 band. This screenshot here shows an 85 megahertz unit that was transmitting in the 5 to 42 band. And I'm sorry, it's such an eye chart, you probably can't really see the readings there. But the gist of it is that there's substantial noise that will be leaking out, essentially, of the D to A above 42 megahertz because there's no longer a filter there to block it inside of the unit. So if you put this unit into a plant and you still have qualms going all the way down to 54 megahertz, then when the modem transmits, this low-grade noise will pick up the noise floor and could lead to macro blocking, pixelization. If you're still running analog down there, it could lead to a snowy picture. Now this can be prevented with filtering, and it's just something else to keep in mind when you're looking at CPE products and you're looking at a deployment strategy. Choices will need to be made about how you want to deploy these units within the house. And I'll show a couple examples about this in a minute. So just to take a quick look at the expanded DOCSIS 3.1 downstream and MoCA. DOCSIS 3.1 specs actually all the way up to 1.8 megahertz, but the must band goes up to 1218 megahertz. And this substantially overlaps with MoCA. If we look at MoCA 2.0 in particular, MoCA 2.0 actually has two bands, a low band and a high band. That's low D and high D. And for those two MoCA subbands, the MoCA spec does allow them to run independently, and a MoCA 2.0 network could exist in the high band without overlapping the must band of DOCSIS 3.1. But again, the filtering is going to be key here to make sure that the MoCA transmissions, which would effectively look like adjacent channel interference and out-of-band noise, to make sure that none of those signals will cause interference back into the DOCSIS 3.1 receiver. There's also a lot of MoCA already deployed out in the plant, and it will be important as we start using these higher bands to make sure that any MoCA households that are even next door to a DOCSIS 3.1 deployed modem have their PoE filters in place so that there isn't any signal leakage that could cause problems for the DOCSIS 3.1 modems. So just to briefly cover a couple of possibilities, when you're looking at how would you install this new box in a home, one possibility is you would install it more or less like a cable modem now, but you would need to install a filter, and I've shown that in blue. And this filter needs to at least have a notch that lets the 5 to 42 still go in, so say an old legacy set-top box can still work. But it needs to notch out the 54 to 85 band so that when that cable modem is transmitting, or really 42 to 85, so that when this cable modem is transmitting, its reflected signals or leakage signals are not going to interfere with these older equipment. One question that we're all still looking at is this blocking filter can easily separate an existing MoCA network from the new DOCSIS 3.1 modem. A complication here is, well, what if that gateway also needs to support MoCA? And one possibility that is being discussed in the industry is you could use a cable modem or gateway that now has two connectors. One connector that looks toward the HFC and another connector that looks toward the home. This has a couple of benefits. It keeps those 85 megahertz transmissions strictly out of the home. It keeps MoCA out of the HFC. No more worrying about whether or not someone has installed that pesky PoE filter. And it may allow frequency reuse between MoCA and 3.1 of the lower D band, but that's going to be very dependent on how much filtering can be accomplished in this modem and how much signal needs to be passed through. Is it sufficient to pass through below 200 megahertz all the way down to 108 megahertz? As George suggested in his presentation, if DOCSIS 3.1 to use the highest order modulations was put in the low end of the downstream band, potentially the frequency split that actually has to get passed through here could be higher up if that's where the qualms still are. And I think the other suggestion here is, for these older set-top boxes, is this the time to, as a 3.1 rollout approaches or is well underway, is this the time to begin planning to transition those legacy boxes to IP, either by replacing them or updating their firmware so that a minimum amount of pass-through of spectrum is actually needed. And with that, I'll say thank you for your attention, and I will pass this over to David Clausen from Charter.
Great. Thank you, Carol. So the Charter perspective on DOCSIS 3.1 and CCAP is more or less that DOCSIS 3.1 is another tool that we already have in a pretty well-stocked toolbox. And DOCSIS 3.1 is going to be an important part of our technology roadmap. But there are other solutions out there that support gigabit speed. I mean, DOCSIS 3.0 can be made to do gigabit service, although it's somewhat intractable. It doesn't extend well. The dilemma that we face at Charter is which architecture is most future-proof. And, I mean, all the choices are ultimately reversible. Some of them are less so. I mean, really, it's going to boil down to the timing of the technology. It's going to boil down to the competitive environment that we face in any given service area and our long-term strategic goals. I mean, these are going to affect the timelines and how aggressive or not we are with deploying upgrades in any given area. So I mean, managing and planning the technology transitions is really going to be the key to the success. I mean, Charter's in a slightly different position from some of the other operators in that we're looking at doing a number of upgrades simultaneously. And so as a result of that, we may be driven into doing things a little bit differently. One of the things is because we are at a slightly different point in our development and deployment program, we've got different complementary architectures that are available to us. So, I mean, we've got your traditional CMTS, CCAP type architecture with large head ends or large hub sites, and, you know, the architecture that we all are familiar with traditional HFC. Going down in the future, you've got remote PHY, you've got different flavors of that with remote MAC-PHY, you've got remote CCAP out as a potential option. There's RF over glass, which plays into when IP video and that transition actually takes place, as well as, you know, ultimately going fiber deeper, which can mean either, you know, reducing node cascades or, you know, even fiber to the home or fiber to the business. So what we're looking at Charter is really to select the best architecture for each service group or each serving area. And I mean, again, this is going to be influenced more by growth prospects in the business environment as well as the competitive pressure. So we're trying to be more evolutionary about it. So we want to think about how we are going to evolve not only from 3.0 to 3.1 and as well as to CCAP, but what is going to actually be beyond CCAP. So those are the items where particularly like the IP video transition is going to be something that is going to affect what we actually do in the outside plant. And the ultimate goal is for us not to strand too much capital out there, with, you know, potential technologies that may find a dead end, and depending on when the timing windows actually evolve, it may be when we make our decision. So a few practical matters. George did a very good job on discussing the technical practicalities of DOCSIS 3.1. And so I will go over this just briefly. But the initial studies indicate that we expect to see somewhere between a 25 and 50% increase in throughput using OFDMA in combination with LDPC over QAM with Reed Sullivan without substantial inside plant or outside plant work. It's really going to be dependent on the current state of any given network segment. Obviously, better segments are going to benefit from a higher multiplier bandwidth increase, whereas, you know, the ones that are in poor condition aren't going to see as much benefit. And depending on where we're at, you know, DOCSIS 3.1 isn't necessarily going to be a panacea. It will buy us a fair bit of bandwidth, given that we're expecting somewhere in the order of about 50% consolidated growth rate of demand. So that we're looking at that, you know, DOCSIS 3.1 giving us somewhere on the order between 6 months to 18 months, depending on which growth markets we're looking at for bandwidth, before we need to start doing some type of plan augmentation through modification. Again, the 3.1 will be deployed, you know, because it solves quite a few of these problems, and it buys us some time. Ultimately, though, I mean, in some of these areas where if we're looking at areas that we're looking at engineering that aren't necessarily in the best of shape, we're going to have to make a decision here because we're looking at doing a full plant rebuild to make DOCSIS 3.1 practical. At what point do we make a decision and say, well, do we push fiber deeper into our network? Do we take it all the way to the home? And ultimately, our business customers are going to be driving a lot more of our bandwidth than our generally mature residential markets will be. So, I mean, we'll go through with, you know, what margin is acceptable for 256 QAM today is generally going to be acceptable for 1024 QAM using LDPC. It's going to probably be marginal for 4K QAM. Each major step, going from 64, 256, 1024, and so on, requires on the order of about a 3 dB increase in signal purity out there on the network. So by the time you get past 4K QAM, the potential bandwidth increase that you're looking at to go from, say, 4K up to 16K is somewhere on the order of 8 to 12% improvement. And so right out there, it's becoming a point where we're not necessarily certain where do we go, do we bother hardening the plant that much, and if we do, how are we going to actually approach that? So a few things for maximizing DOCSIS 3.1. In order to reach these higher required modulation And this isn't quite a 1, 2, 3 cookbook, but it certainly could serve as a decent guide. First thing would be to eliminate amplifier cascades, and to go from n plus many down to n plus 2 or 1 or 0 would be ideal. So again, how much work that's going to be required is going to depend on the current state of the network and the architecture. If it's in good condition, then going from n plus many, n plus 2 may make sense. If it's looking at a full rebuild, then maybe n plus 0 may make sense, because ultimately the most expensive part of doing a network upgrade is pulling fiber, physically going out and touching the plant. After that, we're looking at replacing analog fiber with digital fiber, and it's really not the fiber, it's really the optics. It's replacing the analog, the amplitude modulated lasers with the Ethernet style links. The question is, at that point, though, what do you do with what we consider to be linear MPEG television as we know it today? And that also stands for BOD, but it's really MPEG TV. So do we go, and this is what Carol touched on, is do we then basically step up and transition over to IP television? And so does IPTV come first, or does it come later? Does it come at the same time? Again, that's going to affect what we actually go and deploy in the field. And then, ultimately, as we remove the amplifier cascades, we've taken fiber deeper out of our network. We're looking at probably pushing some sort of a remote PHY or fiber to the to the DMARC, to the home, to the whatever. So at that point, then remote PHY, remote MAC-PHY, remote CCAP, or some sort of fiber technologies need to really be considered as a viable destination. So making this transition that we're looking at Charter going from 3.0 all the way out to fiber to the home is what we're trying to consider and how we make this all fit together. So the Charter plan is essentially we're in the middle of doing a digital video transition right now. So we're doing analog reclamation. We expect that to be completed here during the 4th quarter of this year. So by getting rid of all the analog carriers, we've got a lot more digital video available. We have a set-top box or DTA available at every television set. So that's going to open up a lot of spectrum to support high-speed internet speed upgrade. We're going to upgrade to 16 DOCSIS channels in the downstream with plans to deploy 32 single-PON carriers. And this is before 3.1 devices become widely available. And even after they become available, we'll probably still deploy these in a DOCSIS 3.0 mode for a while until we free up the spectrum and get everything lined up to be able to fully support 3.1. As we upgrade from our 30 meg to 60 and 100 meg speed increases, that's going to lay the foundation for an IP video transition, because we'll be able to support being able to actually roll enough bandwidth to be able to support high quality video. So currently in the labs, we've got we're doing research and development. We've all of our different CMTS platforms and CCAP flavors from a lot of different vendors. We're also looking at a wide variety of other technologies that include fiber, that include wireless, both as a backbone backhaul technology as well as for potential last mile applications, even to use these to bridge potential areas where we've not been able to provide service. Our footprint is a little bit different. We're more of a rural player, so backhaul is a much more important part of our network calculations than a more urban-based provider would be. We're doing a lot of internal education research. We're trying to understand what the ROI is for deploying OFDM. We're looking at working with the outside plant teams to understand what the implications are to the plant and to decide and come up with essentially an action plan with how do we make the most of what we have, how do we make sure that we're not deploying technologies that ultimately end up being scrapped if they turn out to be a dead end. As far as development, we expect to deploy CCAP probably first. We expect to deploy remote CCAP essentially as a remote, as a spot solution, depending on where it fits and if it makes sense and it's viable technology. DOCSIS 3.1 is going to be in there as part of that mix. Again, it's really going to boil down to when all these technologies end up lining up together. And with PON, we're really looking to understand what the business case on that is. Because obviously a full plant rebuild is quite expensive. And it doesn't play well into just jumping from where we are all the way out to the end game. While that would be ideal, it's probably not realistic. And some sort of evolutionary plan to evolve our network, our bandwidth capacity, to be able to serve our customers and meet the competitive pressures that we face is going to be what's in mind. So for future points to consider as well, seems to be taking a little bit of time to load. But I've just got kind of an idea map here for different things that we're considering at the moment. We're looking at fiber to the home. We're looking at what impact business services have. When does IP video become viable? How do digital optics play in? Which digital optics to actually deploy? What is our outside plant going to be capable of? What kind of education do we need? What is the impact of 4K TV going to be? What's the government going to be doing, both from a regulatory standpoint or from a licensing or access? No presentation these days would be complete without mentioning software-defined networking out there. So what is that going to do to CPE? How smart does the CPE device need to be in the home? At which point do we physically disconnect the CPE device from the actual HFC network or optical to eliminate some of the crosstalk issues? So that's down the road. What's the impact of wireless, both as a last mile or last quarter mile or even the last few hundred feet to serve as a drop technology? What does that actually do for it? Also note there's plenty of empty space in there because there's a lot of things that we know, and there's certainly things that we are aware of but we don't necessarily have a good view on. But these are the types of things that we're considering at Charter and how to push this all together in order to make a viable solution for everybody. Anyways, thank you all for your time. I've left my contact information here. If anybody has any questions, feel free to reach out to me. So thank you very much.
All right, David, thanks. Okay, so we can move right into Q&A. Keep those questions coming, and we'll get as many answered as we can in the time we have left. The first question we have came up during your presentation, David, and you may have, I think you kind of answered it, but we'll start with you and then we'll switch over to George. To the service providers, how seriously are you considering an on-off keyed system like EPON or GPON versus RFOG or standard HFC?
We're looking at it quite seriously. It really is going to depend on the area that's being served. So it's definitely on the table for technologies that can be deployed in parallel with DOCSIS 3.1.
George?
Yeah, in our case, we are currently trialing EPON deployments, 10 gig EPON deployments, and so we not only are we thinking very seriously, we are actually working on deploying it.
Okay. All right, so Carol, question for you. Maybe, I don't know if it's out of your area, but we did get to kind of a time frame from Charter and Comcast. As far as Europe goes, can you comment on the deployment scenario, I guess, for 3.1 over there in CCAP? Is that something that's ahead of us or behind us, or?
I think it will be very similar. It may follow slightly behind. There's definitely not more of a driver there, but a lot of the European plants do have a lot of spectrum available, so they don't have quite the spectrum pressures that are present in North America. So we're just going to have to see.
Okay. All right, fair enough. Question number 2 in the highlighted tab is from Marwan. Has anyone done any RF characterization or performance of high-order modulation? It says half 4K on drops. Is that a question you can answer, George?
Yeah, this refers to 1, 2, or 4K
okay.
drops. Yes, so Marwan, yes, we have been doing work on characterizing all of the components of the RF plant, and we're actually now doing. We just bought some equipment to do testing of 4K QAM. The equipment that we bought can do 4K QAM on 100 megahertz of OFDM, and so we're actually going to be testing it in the actual plant. We're freeing up the spectrum in order to do that, so we'll do it in live drops and live plant. So yes, we're doing that, and it seems to work.
Okay, great. Okay, so on to our next question. I think this, I don't know who exactly we can point this towards, but is there any effort to standardize testing so that the devices from different providers can be compared? Why don't we throw it to you, Carol?
Well, I think the largest amount of standardization will probably come through Cable Labs and Accentus in Europe. From the vendor's perspective, you know, we want to work with everybody because it's all, I mean, that's been the biggest success of DOCSIS, is having equipment that can work well together. It gives all of us vendors an advantage. It's to no one's advantage to have a product that doesn't work with other people.
Great. George or David, anybody want to add to it?
I just echo what Carol said. The test industry, industry testing will happen at Cable Labs. We are, very strong member of Cable Labs, very strong supporter of what Cable Labs does, and we're actually working with Cable Labs on determining how will DOCSIS 3.1 certification occur and coordinating our testing so as to avoid overlaps with Cable Labs. So I think that's where industry testing is going to be, and that's where products will be compared to each other. In addition, we will do our own testing as well, but our testing is focused on our way of operating the units. So we test our own operational interfaces and tools, et cetera, to make sure that they work properly. But the majority of the comparison will come, not just a comparison, but compliance with the protocols and specifications will come from Cable Labs.
Okay, well, we had another question come in as you guys were answering that one. How about certification of OSP? Will we have standards there?
Of OSP, you said?
Yeah.
Outside plant. Oh, well, that will be done by each individual MSO. We will do ours. In fact, we're trying to determine what are the, as I said in my presentation, what are the appropriate metrics and what are the standards we should apply to each one of these metrics. So I think each MSO will do their own.
Okay. And moving right along here, this is question number 6. George, how do you see the revival of RFOG with DOCSIS 3.1? Could a wide upstream carrier, 48 megahertz / 98 megahertz, solve the OBI issue because then only one modem at a time would send data? Or do you expect new problems with the burst mode upstream due to the OFDM modulation?
So 2 things about this. One of them, let's break down how do I see the revival of RFOG, and then what's the implication of DOCSIS 3.1. So as it turns out, there is a bit of a revival of RFOG going on, and that is due to not just a few, but generally all MSOs looking at deploying fiber-based service. In our case, we've been deploying fiber-based services for quite some time. We have a whole Metro E platform and services that go along with it. So we've been deploying fiber-based services for quite some time. And in some of those locations where we have fiber going into, say a building or an office or whatever the case may be, and we need to deploy some HFC-based services, for example, a set-top box, right? And we've been using RFOG for that type of an environment. And now as the number of these fiber-based installations grows, there is a bit of a revival of RFOG going on. We know as we talk to vendors that they're getting orders from just about everybody across the industry, not one or 2 MSOs, but rather a large number of MSOs, and the number of orders are increasing. Now at the same time, of course, every MSO, us and others, are developing an IP video infrastructure, and so that will tend to curtail on the amount of RFOG being deployed. So that's one thing, right? There is an RFOG revival going on. With respect to DOCSIS 3.1, well, yes, there could be some benefits from the use of a wideband carrier and a single modem transmitting at any one time, but that is unlikely to be the case in practice, because in that same network there'll need to be DOCSIS 3.0 and DOCSIS 2.0 modems that are currently deployed, right? So you'll still have DOCSIS 3.0, DOCSIS 2.0 and 3.0 modems using single carrier QAM burst in that same portion of the spectrum. So there'll be multiple modems transmitting simultaneously. And I think, in fact, the number of modems increases and the number of channels increases, and so the probability of OBI increases, irrespective of whether DOCSIS 3.1 is added or not.
Okay. David, anything on that one?
No, I think George pretty much got that covered.
Okay. David, we'll switch to you on the next question, question 7. Will CO, I'm not sure what that stands for, will CO extend the opportunities of DOCSIS 3.0 by splitting final optical node with less RF branches and remote CMTS?
Well, I mean, certainly by splitting out and reducing the amount of RF branches and pushing remote CMTS or pushing fiber deeper out, what you're doing is you can extend the life of DOCSIS 3.0. I mean, ultimately we're going to be limited by what the chipset technology is, and it would seem that we're more than likely going to be stopping at probably a 32-channel device. At least that's what I've seen so far on product roadmaps. I don't think there's anything that's really beyond that. Now, that being said, I mean, those DOCSIS 3.0 devices are going to be deployed in the field for a long time. But as soon as 3.1 devices become available, we're going to be starting to purchase those, even if we continue to operate a given network segment in a 3.0 configuration. But certainly 3.0 does have some life left in it, and by pushing fiber deeper and doing node splits, it certainly will keep that a viable technology. I mean, ultimately, it's really going to determine. The transition is really going to be determined by what the bandwidth demands are on any given segment, and whether the CPE device will actually be able to support what the given subscriber needs.
Okay. Carol, with 3.1, will there be any new support to have the CMTS calculate distance from fiber node or head end?
I think there's going to be a lot of new features that will be added in because we're going to have a lot more capabilities to try to pull information out of the system. Whether we'll try to target that particular feature, I don't know. I'm not sure I see a direct need for that. I think the things that will be more interesting will be, will we be able to keep out all of the other devices that will be showing up in the 700 megahertz band and 900 megahertz. There's going to be a lot of other chatty devices, and when you've got it, and George had alluded to this earlier, when you've got a really wide signal and you're experiencing degradation in some of the subcarriers but not others, how are you going to track that back? What's the best way to report those problems and solve them? I hope that was helpful.
Okay. All right, so here's the question for George and David. Why don't we start off with you, George, and then we'll go to David. There has been mention of SCDMA for use below 20 megahertz. Does Charter and Comcast see this as a value, or will the end result be attempting to use OFDMA below 20 megahertz?
Yeah, so we have, I think we have all operators have tested SCDMA. And there's definitely value in using SCDMA below 20 megahertz. But the implementation of SCDMA has taken much longer than any of us would have wanted to, for different reasons. But the main one was, as operators, we were not using multiple upstreams or enough upstreams to need to use the spectrum below 20 megahertz. In the case of Comcast, we've had 2 and 3 upstreams in the majority of our footprint, for many years now, and still until now. And because of that, we didn't really need to use the spectrum below 20 megahertz. And because of that, vendors such as ARRIS and others have not dedicated time to implement all of the nifty features of DOCSIS, of SCDMA that are in DOCSIS 2.0 and 3.0, because it really wasn't necessary. And now, as we expand the upstream capacity, because upstream utilization, keeps increasing, at a reduced rate than downstream, but it keeps increasing, the DOCSIS 3.1 becomes available, and with that, OFDM becomes available. And so it's not clear whether it will be necessary or not to continue supporting SCDMA moving forward as we move into DOCSIS 3.1 era in which OFDM is supported. OFDM has all of the characteristics of SCDMA and a few more. It's more efficient in the use of upstream, and so it may be that the time has come to, instead of planning to use SCDMA in the upstream below 20 megahertz, we plan on using OFDM, the upstream below 20 megahertz, and that might be just okay and more efficient for us as an operator and for the equipment vendors as developers of functionality. Hope that makes sense.
David, same question over to you.
Certainly. So with respect to SCDMA, as George said, SCDMA does have applications that are appropriate. Given Charter's footprint, we have not, up to this point, seen the need to deploy SCDMA. I'm hesitant to say never, but like George and like Comcast, I would expect that we would be moving forward at Charter, deploying OFDMA in the upstream. Again, I don't see a lot of application for it, and it increases a lot of operational complexity to be able to manage different modulation profile like that, especially given that it doesn't have unified support across the vendor base.
Okay. And this question, number 9, looks like it would be good for you, George. When do we expect CCAP will be truly enabled through converged delivery of both data and video through the same EQUAM?
Yeah, so we're testing that right now. Actually, I guess this is a gradual thing. We've been deploying VOD integrated with video. We're now working on the integration of encryption, linear encryption, and so starting next year we'll start deploying integration with linear encryption. So there's a collection of things that has to happen. Another one is, of course, the availability of the equipment that supports the wide spectrum required for all video and DOCSIS, and that's just now becoming available. So I think starting next year we'll see pretty broadly an integration of video and DOCSIS. We're certainly deploying and testing and deploying it already.
Okay, so we're headed into the home stretch here. We're down to the final minutes of our hour here. Why don't we just go around the horn one more time? Any final thoughts? David, anything that you could pass on to somebody else? As you said, there's a lot to plan for. There are different options out there. Any maybe lessons learned that you would like to pass on? Same thing for you, George. And then Carol, we'll finish up with you. And I don't know if you can speak to smaller operators and how they fit in, but just final thoughts for everyone, starting with you, David.
My final thoughts is weigh the decisions carefully. There's a lot of options. There's a lot of technology that we're in a confluence here with, and you really have to choose carefully to make sure that you're making the right decision going forward.
Okay, George?
Yeah, so 3 things. First is, since this is about DOCSIS 3.1, DOCSIS 3.1 is going to become available, starting in 2015. It's being developed much faster than any of the previous versions of DOCSIS. The specs were developed faster, and the equipment is being developed faster. So starting in 15, it'll start to become available. I guess the second message along the lines of what Dave just said is, and DOCSIS 3.1 will be one more tool in our toolbox, right? We have DOCSIS 3.0 deployed everywhere now, at least a whole lot of 3.0 modems. In many cases, operators are taking out 2.0 modems. We're not doing that, but others are doing that. And so 3.1 is another tool in the toolbox, together with 3.0 as it exists today. And so a gradual and thoughtful migration will make sense. And then the third one is, there are technologies being developed now, for example, as Dave mentioned, fiber deep, and all the technologies that go along with fiber deep, such as remote PHY, remote MAC PHY, and then fiber-based services. And so, to Dave's point again, I think that it's incumbent upon us to make sure that we deploy the most appropriate technology in each one of the cases. It may be different for some locations than others, for example, MDUs and SFUs, and it may be different in highly dense populated areas than in lower density areas. We have a lot of tools. The time ahead of us for access networks has never been better. It's amazing how much evolution there is. And so that makes more tools available, and we will have to determine which one is the most applicable and cost-effective in each location.
Okay, Carol, we'll finish up with you.
Okay, no pressure. For the smaller operators, I guess I would echo some of what David was saying, is that DOCSIS 3.1 offers very interesting tools, but you're going to need to carefully evaluate. A lot of operators, especially smaller operators, serve a wide variety, everything from college towns where there may be a lot of pressure for 3.1 gigabit speeds, being able to offer very competitive high-speed data packages, On the other hand, if you're in a much more rural setting, 3.1 may not fit for a while. You may want to give it some time and carefully evaluate, what is it going to offer you, what impacts will it have, and what advantages can you get out of it. And I'll leave it there.
Okay, well, that's going to wrap up our webcast for today, Managing the Transition to CCAP and DOCSIS 3.1. I want to thank ARRIS for sponsoring it. I also want to thank George Salinger, Carol Ansley, and David Clausen. And make sure that if you're going to Expo, you get to that pre-symposium that's the day before Expo starts. But thanks again for everybody joining us today, and that's going to do it for us. Thanks.